So the question is, you have a linear function. What can you say about its concavity? Okay. All right. So line just said that to not have any concavity, or have zero concavity, and that's because the slope is constant. Or we said earlier that the average rate of change is constant. So lines don't have concavity. Okay, let's talk about parabolas. And given the graphs we drew, we kind of know that these things have some concavity, right? So let's consider a simple example like y equals x squared. We know what that graph looks like. Here it is. And we can even see it. If we look at it, here's the slope. That's something positive. Here's another slope out here that's something positive, but a bigger number. So this seems to satisfy the fact that as x goes up, slope goes up. Now, just to make sure you were paying attention, is that true on the left? Let's look at the left side of the graph. Is that still true? That as x gets bigger, the slopes get bigger. So this slope might be -3, and that slope might be, I don't know, -1. I'm not really being precise about this. And the question is this fact true? As x went up, did the slope go up? And the answer is yes, it does. Because -1 is a bigger slope than -3. Again, don't confuse how big a slope is with how steep a slope is. Those are two different things. Okay? All right. It is sort of fun to see this numerically. I mean, we've been looking at pictures here and so forth, but with y equals x squared, we can actually verify that this thing is concave up. So we're going to make a little chart here, x and y, and we'll put some numbers here. And then we'll quickly get the y values. So if y equals x squared, then this has got to be 4 and 1, 0, and 1 and 4 and 9. Okay. So we can tell a little bit about this thing. We can say, all right, so if we look here at 0, we notice that for these values, x was going up for these first two values, right? But as y went down, so the function was decreasing for a while, okay? And then for these values on the bottom here, we notice x is going up as y is going up. So the function is also increasing for certain domains. But what about slope? That's what we're going to look at now. We're going to look at slope to see about concavity. Ready? Let's do that. Okay? And to do that, what I'm going to do is I'm just going to rewrite these y values again. I'll call this column M for slope. This first slope for these 2 points, if we think about it, we can actually figure it out. We can do 4 minus 1. I'm subtracting the y values over -2 minus -1. So I did 4 minus 1 over -2 minus -1. That's 3 on top, -2 plus 1 on the bottom. So I get a slope of -3. Okay, so that's our first slope. So now what I'm going to do is compare that to the slope that comes right afterwards. So here you go. So for this slope, it's going to be 1 minus 0, because that's my change in y. There's my y values, 1 minus 0, over, now I've got to be careful. I'm going to do 1 minus 0. I've got to do -1 minus 0. That gives me a slope of 1 over -1, which is -1. What do you notice? The slope got bigger. We had a slope of -3, now we have a slope of -1. Let's keep checking. We'll do the next slope. Here it is. Okay? So this slope is going to be 0 minus 1 over 0 minus 1, which gives me -1 over -1, or 1. And the slope got bigger again. So this is confirming what we were saying, is that the parabola is concave up, or at least the parabola y equals x squared is. Okay? If we check the next slope, it'll be 3. The slope after that, I think, comes out to be 5. sort of an interesting pattern in the slopes that's worth discussing in a different video maybe. But what we've seen or shown is that as we move to the right, our slopes get bigger and bigger. So this function, y equals x squared, is concave up, always.